So we can see a line graph is used to show difference or comparison between two sets of data, standing vertical jump or standing broad jump, and in other cases how your results would develop over time. So time might be at the bottom axis, and then you could see how the scores developed over time. But in this case, we've got the participant number on the bottom and scores at the top, so we can see where the participant scored. It's easily depicted. You can visually see what the participant scored, how they vary from the other test, and how they vary from each other, and they're quite extreme variance. So these error bars or standard deviation bars basically show the vary in the results, and basically if they overlap, it means that the data is likely to be statistically significant to each other. If they do not overlap and are nowhere near each other, it means that the data is not likely to be statistically significant to each other. And another benefit is that you can use multiple sets of data at once in a line graph. So moving on to histogram. Histogram is basically a frequency-based chart. So we can see that 14 participants scored between 1.95 and 3.75 in the static and flying sprint times. No one scored any in 3.75 to 5.55, and one participant scored 5.55 to 7.35. And we can see that basically in the intervals you would have the frequency, so the amount of times that interval had been basically the score of that participant had landed on. So we can see 14 people had a score in 1.95 to 3.75. And this basically is easily depicted. This graph is used to show the distribution of values between participants in the data, and it plots data with the range of data into intervals. And a plus side of this is that you can see the data easily. Straight away you can see that between 1.95 and 3.75 was without a doubt the highest, and also it means that everyone knows that the whole group was placed, basically the whole group apart from one was placed in this interval. A negative to this, however, is that it is not very descriptive of why or the individual scores. So it basically just lumps everyone together in one block. It doesn't allocate individual scores to each person, or it doesn't tell you why there was an anomaly like the last person, or there was no people in between 3.75 and 5.55. So moving on, we move on to the table and box and whisker. So tables show exactly the results and are easy to read and understand with clearly laid out columns and headings. The data can also be easily manipulated, rank order and range, for example. So this is a benefit, because if you needed to manipulate your data to get say the mean, or to basically see the data more clearly, you could rank order the data like it's been rank ordered in the standing vertical jump column here. And it makes it more clear and easy to read. It hasn't been rank ordered. Sorry, but if it were to be rank ordered, it makes it more clear to see to people that are looking in the study. However, it is not as visually easy to view as, say, a bar chart or a box and whisker graph, which is to the right of the table, which visually shows you straight away how different each score is from each other, and it's more straight away. It is more easy to identify the difference. Whereas in a table, you would have to know what you're looking for. So a box and whisker graph. This graph basically shows the extremities and quartile ranges of the values. So the box and whisker graph is similar to the line graph, however it can show much more information. It also includes quartile ranges, basically what I've just said. So in this one, there's the days and then time slept, hours on the side. So these bottom lines, it shows the extremities. So 4 would be an extremity, and 9 would be an extremity, and these lines here are called the whiskers. This box is basically the quartile range. This is the upper quartile, this half of the box here, and this is the lower quartile, and this line through the middle is the median. And this can give a lot more information to who is viewing the study. These are also anomalies, and an advantage to using the box and whisker is that the graph itself doesn't actually include anomalies. And as we can see, it also sort of eliminates the extremities, whereas other graphs, like the line graph, for example, would keep that extremity in there, and it would sort of skew the data so that it made it look like there was a really high value when it was actually a mistake, or there was an external or internal factor affecting that result. So the box and whisker graph gives a lot more information, and yeah. So normal distribution. Normal distribution is, it basically refers to if the normal distribution curve is what you can see here in the graph. Basically refers to the data being normally or equally distributed on either side of this curve in a symmetrical fashion. So and basically when both sides of the curve have equal or even data, the curve is a symmetrical, perfectly symmetrical bell shape, it will be referred to, and this is referred to as a Gaussian distribution curve with even values on either side to form the bell-shaped curve. So it states that for this bell-shaped curve to happen, that 68% of the data in the curve needs to be between +1 and -1 of standard deviation, 98% needs to be with +2 and -2 of the standard deviation, and 99% needs to be within the +3 and -3 of the standard deviation. This is the empirical rule and means that either side of the curve is equal and obviously normally distributed. The curve can be as tall or as short, but as long as the curve is symmetrical, it means that it is normally distributed data. So moving on. Asymmetrical distribution curve. This is the opposite of a normal distribution curve, and it doesn't have equal values on either side, and this is what causes the skewed distribution curve, which is what you can see as negative skew and a positive skew. So a positive skew curve is when the tail faces the higher end on the chart, whereas a negative skew points to the lower end of the chart. So a left skew left skewed data set was in the median and the mode is greater than the mean and have a negative ending, and the right skewed data set is when the mean is greater than the median and the mode and it has a positive ending. So that means that this negative skew here. Moving on to outliers. An outlier is a value that does not closely share the same value as the other data. Outliers can skew results and make the final data set unrepresentative of the values inside it. So outliers create distortions in data as they do not represent the other values in the data and therefore skew the results. Outliers and anomalies are values that have had an external and internal factors affecting them, which were not the same as the other values, which mean that the results come out differently. They need to be identified as outliers because otherwise they will be regarded as accurate results that will be included in the final presentation. There are ways to take away anomalies and outliers easily, however, to make sure the data does not become distorted. So I will now move on to how to get rid of these anomalies. So trimming and Windsorizing are the two ways that you would do this. So trimming. This is the action of actually removing both of the value, say on this diagram, for example, both of the values that are considered anomalies. So 2 is considerably lower than 10 and 22 is considerably higher than 14. So to stop this being an anomaly or an outlier, you would simply just cut them off and get rid of them basically, so there's no data that will skew the final results. Windsorizing is a bit different. However, instead of cutting these two numbers off, you would instead replace this number with the legitimate next number in that order. So 2 would become 10, and 14 would become, 22 would become 14 as well. And in this way, it's not skewing the data because these are already legitimate results that were recorded. So moving on to quantitative data analysis techniques 4.5.3. So this is part 3 of the assignment, the theory, descriptive statistics. So these are the central tendencies: mean, median, and mode. So starting with the mean, it is equal to the sum of all values divided by n, which means that you have to add up all the values in the data set and divide it by the amount of values that are in the data set. So the benefits of the mean: it includes every value in the data set, meaning it is representative of all the data. It is an average, so it draws good conclusions from the data. So basically, if you take the value you find when you get the mean from the data set, that is representative. Its limitations, however, is it is susceptible to influence of outliers, especially when sample size is small. So this relates back to when I said that it includes every value in the data set. This can also be its downfall, because if there is an outlier in that data set, it will also include this, and therefore skew the data, and it will be a misrepresentation of the other values in the data set. It might make the data extremely high or too low. The mean cannot be used in nominal or ordinal data either, which could halt some people's, if someone was planning to use the mean when they had ordinal or nominal data. So now looking at the mode. The mode is the value that occurs the most often, and this is found by viewing the dataset and seeing what value has appeared the most amount of times, or the most frequent value. This is the mode. So the benefits can be determined graphically, and it's easy to initially spot and point out in the dataset. The mode can also be used in nominal data, whereas mean and median can't. And the limitations are if there are more than one modal value, then the data has to represent two values, meaning that it becomes bimodal, and this can make the data a bit more complicated than it would be if you're using another descriptive statistic. Some data, such as continuous data, aren't likely to have a modal value. It doesn't represent all the data in the set, and this is because you're picking the data which has been frequented the most, and you're sort of disregarding all the other data in that set. So the last one, median. To find the median, the first step is to rank order the values from the highest to lowest. Once this is done, you need to find the middle value, which is literally done by finding the middle value by elimination. If there are two values directly in the middle, then you need to average them out by finding the mean. And this is done by the same process, where you add both and then divide by n, so divide by 2. And then that's how you get your median. So the benefit is that it is less affected by outliers, not as strongly influenced by skewed values. To calculate the median and find middle number, or add middle numbers and divide by 2, and it's easy to find the median, but it can be time consuming if the dataset is quite large, and this will take a long time to eliminate all the numbers and find the middle set. So the limitations to the median are slow to calculate with large datasets, not ideal with small datasets, as it means the median